advise that you drop off the call so that you can at least get to a safe place and then join us when you get to your destination. But outside that, I look forward to a wonderful session, and do have a wonderful time here. Thank you so much. Cheers.
Thank you very much, Opere. Safety always there. Thank you. Thank you. And now the ground rules have been set, safety precautions taken. I'd like to make welcome the number one chief servant, the brain behind the activities of what happens in SPE Port Harcourt. I'd like to make welcome the section chairman, Daniel Abia, for his opening remarks. Welcome, sir.
Thank you, Technical Information Chair. Good evening, ladies and gentlemen. Please confirm everyone can hear me.
Loud and clear.
Okay, Simon, please.
We thought you were going to do us the honors to turn on your vid if your bandwidth could carry it so that we can also see you.
Maybe before the end of the presentation, I will try to get to a better network.
Okay.
Okay. Simon, please try to admit some persons. I see them in the waiting room. First off, is to really appreciate our speaker for this event. I mean, we met on LinkedIn, and okay, so the rest is history. But many thanks to our speaker. I send this request to him, and he to join us in a monitoring meeting and make this presentation. So I would really Dr. Fatai for accepting this our request, and then going through all the hurdles of getting a date, rescheduling the dates, and then the dry run. Thank you very much, Doctor. And thanks to Saudi Aramco for permitting you to make this presentation to SP session 103. Many thanks to our moderator. I mean, in a very short notice, Mr. Michael Aku also accepted to be the moderator. I really appreciate these two persons in the call, and also to all our SPE members, like our commitment when we took over the board here to provide content, technical content to all our monthly technical events. The topic is quite very, very interesting, finding opportunities for machine learning applications in the energy industry. So the industry, it's the energy is on transition from oil and gas to energy. Okay, so I look forward to having a very interesting session. And Dr. Fatai, our presenter, I've been going through his articles on LinkedIn, and I'm really telling us, sit back to grab your pen, grab your notebook. I'm sure we are in to learn something new. You will agree with me that artificial intelligence is actually a disruption. It's a big disruption, and it's changing so many things, almost 360 degrees. I look forward to having very pleasant new knowledge. And I also want to apply this knowledge in my organization where I work, which is Total Energies. Thank you, everyone. And let's learn, unlearn, and relearn. Thank you.
And thank you very much. No better placed or better put than the SC himself. And if our leader is really eager to learn, I think we all should also wear and embrace the same spirit of learning and relearning. And the topic today is apt and is revolutionizing the industry. Ladies and gentlemen, you're in the right place. Let's sit back and enjoy this. Thank you very much, Essie. I'd like to now invite the PC, Madam Ngozi, to usher us into the main meat of this evening as we get started with the technical event. Thank you, Madam. Over to you.
Good evening, everyone. Please confirm that you can hear me.
Loud and clear, Madam.
Okay. Yeah, good evening, SC. And I also want to recognize Prof. Onyeka, who is on this call. We really appreciate you creating the time to join the call. Thanks a lot. Back to the business of the day. Citation for Michael Aku, who is currently, please hold on, who is currently the digitalization manager for Cypher Crescent Limited. In the Energy Innovation Service Division at Cypher Crescent, he drives innovation, integration of artificial intelligence system in solving challenges in the energy industry. He has managed and developed. He has managed the development and deployment of a lot of applications. He was also a technical lead and focal person in the digital oil field technology space, in which Cypher Crescent is in consortium partnership with Huawei, Emerson, NMPC, IDSL. He's the pioneer product developer and manager of the renowned CEPAL predictive maintenance and CEPAL real-time equipment health monitoring system solutions developed for predicting equipment failure and real-time data management respectfully using machine learning. He was also the co-manager in the integrated asset management team at Cypher Crescent, where he developed the well integrity management system, an application which helps to proactively manage well integrity of assets. Join me in welcoming Mr. Michael Aku.
All right, thank you very much. Introduction, thanks for that introduction. My name is Michael Aku, Cypher Crescent. I will be moderating the session, and I can tell you there's a whole lot to learn from what the presenter has to offer us, of course, with respect to this technical meeting. We are all aware of the buzz in artificial intelligence, machine learning, and of course, the whole wave around ChatGPT, GPT-4, and also how can the industry latch on to what machine learning has to offer, from reservoir to drilling, to production, to process, to HSC surveillance. There's so much machine learning can help to achieve with respect to objectives such as cost reduction, process improvement, and enhancement of safety. Our presenter today is as an erudite scholar that actually captures knowledge across machine learning, both from industry perspective to the academia, and has a lot of experience in using these machine learning techniques to actually achieve his objective. His name is Dr. Fatai Anifo-Oshe. He's a senior research scientist at Saudi Aramco, where he works with the Upstream Advanced Research Center. He bagged his PhD degree from the University of Malaysia in Sarawak, UNIMAS. That was in 2015. He's also a graduate of the prestigious King Fahd University of Petroleum and Minerals University of Saudi Arabia, and got his MSc in 2009, and also had his BTech from FUTA, Ondo State, and that was in 1999. His career has spanned across computational workflow, automation, discovering opportunities for machine learning in the reservoir characterization of petroleum and geology. He has an extensive experience of 23 years in software development and also application of machine learning in advancing of data mining techniques for petroleum reservoir characterization. That span a period of 14 years. He also has reputable papers in journals of interest, where he has published over 70 papers and filed several patents. He also received one of the prestigious awards in SPE, that's the award for the African Regional Service Award for Data Science and Engineering Analytics for the Middle East and North Africa. Ladies and gentlemen, sit back, join me as I welcome to take us through finding opportunities in machine learning for the energy industry. I welcome to take this presentation Dr. Fatai Anifo-Oshe, the Senior Research Scientist, all the way from Saudi Aramco. Thank you very much, Dr. Fatai. Over to you.
Thank you very much, everyone. Good evening. I hope you can hear me very clearly. Can someone please confirm that?
Yes, we can hear you.
Okay, thank you so much. And I hope my screen is being shared.
Yes, we can see your screen.
Oh, okay. Then let me start by switching on my video, hoping that it will be network friendly. And just in case it's causing any trouble, I will be glad to switch it off. So thank you so much for that citation. I couldn't have done it any better myself. And I have to start by thanking Daniel for the invitation. I really appreciate that. I also thank the organizing committee for the job well done, and for accepting all my excuses and accommodating my request. Thank you so much. We have been back and forth a few times. Thank you so much. So the topic for today is finding opportunities for machine learning applications in the energy industry. I have tried to...
Apologies, Doc. We're seeing your video and not your slide. Is there something?
Okay, let me share again. I shared a while ago. I thought it's still there. Let me do that again.
Okay.
Okay. Okay. How is it now?
Yes, now it's up. Thank you.
Okay, thank you very much. So in the agenda, my plan is to go through the following. Basically, the talk will be in two parts. The first part will focus on some fundamental theoretical backgrounds, and I will pass over that very quickly. And the second part will discuss some of the opportunities for machine learning. And of course, there are challenges everywhere. So I will also touch on some of the challenges, and I will present some successful applications in some fields. I wouldn't promise to be so exhaustive in that. In case you find the material too simple, please accept it. It is done in the spirit that I have a mixed gathering, a mixed audience consisting of between advanced, medium, and basic. So I try to maintain a middle course. So let's start by assessing our current situation in the energy industry. Currently, the industry is facing a massive digital transformation, and everybody knows that. There is no denying it. And is also facing a gradual transition to what has been called energy mix, where greenhouse gases are expected to be gradually reduced, and eventually we want to reach what is called the net zero, where there will be zero emission of carbon dioxide and other carbon derivatives. And to achieve this, there has been focused interest recently on renewable energy, carbon capture, hydrogen production from hydrocarbon and other sources, and of course, there is ammonia, all in order to provide alternative sources of energy in order to save the planet. But the bottom line is, according to a lot of experts that I have read their articles and listened to their interviews, the bottom line is that oil and gas will remain the major source of energy to the world for several decades to come. Even if all the vehicles in the world become electric, there are other products that come from crude oil. We have plastics, we have our clothing, we have our building materials, so many things. Even in the worst case, in order to get these other materials going, we will still need crude oil. So exploration will never stop, refining will never stop, and all other activities, including seismic and so on. However, in order to achieve this, either to keep the oil and gas business going, or to even develop some of the alternative energy sources, we need technology. So that brings us to the role of technology in the energy mix itself. Now, when we talk about technology, we talk about the fourth industrial revolution, where we are being faced with a whole lot of various technologies ranging from virtual reality, AI, artificial intelligence, cloud, big data, robotics, and so on. And all these are coming up in order to transform the way we live, the way we work, to transform various aspects of the oil and gas business, from seismic to drilling, exploration, and production. And all these are expected to help us to improve our operational efficiency, to provide real-time data that will be used for real-time decision-making processes, of course, to increase revenue, and also to increase safety, and of course, to decrease risk. However, before we go further into the fourth industrial revolution, it's always good to go to look back and look at what we have had previously. We had the first industrial revolution in about 1784, which was all about mechanization. The second revolution came in around 1870, which was about mass production and electricity. The third one came around 1969, which was about electronics. And that was when microcomputing started coming into our life. Today, we are experiencing the fourth revolution. And this one is different from the other revolutions in a simple way, in the sense that it is massive in its magnitude and as well as in its effect on us, both in our private life and in our work life, because it comes with a whole load of technologies that are here to stay and to change the way we work. Now, what is artificial intelligence? There are so many definitions out there, but I always prefer this one, which is very simple and straightforward, by John McCarthy, a professor in the US. He says, AI is the science and engineering of making intelligent systems. It may not be all-encompassing, but the relevant ingredients are there. It's a science, it is engineering, and it deals with building intelligent systems. These systems can be in form of hardware, software, or even a combination of both. It could be hardware, such as robotic arms to do certain repetitive tasks. It could be software in which we have intelligent applications doing wonderful things, doing what humans can do or even better. And it could be a mix of the two, such as some intelligent rovers that can be launched into some remote areas to do some independent activities and report back to the base station. So whatever it is, we're talking about artificial intelligence. This is one of my favorite slides, okay? And if there is only one thing that I would like people to take away from this part of the talk, which is the fundamental or the basic part of the talk, this is the slide. There is a whole lot of confusion out there based on my experience talking to people, presenting at conferences, discussing with people. People tend to confuse all the technologies. Most importantly, the two major terms, artificial intelligence, which I will henceforth call AI, and machine learning. And sometimes they bring neural networks into it, probably because neural networks was more or less one of the oldest machine learning methods ever created. I was in a conference, one day, some 10 years ago, and you can easily excuse that because it's a long time ago. Someone came to me and said, which method did you use in your work? Is it AI or neural networks. For a few seconds, I was off thinking about, where do I start from? Because the question was fundamentally wrong. So I started by, trying to clear the confusion. And I come up with this, what I call the AI family tree in order to resolve that confusion, to clear the confusion. And it goes thus. AI is on top of the tree. Of course, if we invert the tree, so AI is the root. And when we say AI, in a general sense, we are actually referring to a set of technologies, unless we specify exactly what we mean. When we say AI in general, we might be referring to natural language processing, NLP, which is the branch of AI that deals with, building language systems. Language translators is a good example. The ChatGPT is a good example. It's a kind of NLP, natural language processing. Language translators, like last year, I was in Spain for the EAGE conference. Then I took a cab. The driver did not understand English, and I didn't understand Spanish. So it was through an app that we were communicating. So I will speak English into the app, and he will play it back to himself in Spanish, and vice versa. So that is an example of NLP. When we say AI, it could be expert systems. These are rule-based systems that combine series of if, else, if, and other nested if in order to take users from certain set of inputs into a final conclusion. For example, in the olden days, we used to have medical diagnostics that will take a user input. For example, you have a headache, you can pin, okay, I have a headache. Then it's like a conversation system to ask you for how long now. So based on your response systems. When you say AI, again, in a general sense, it could be robotics. And we all know what robots are. They are mechanical or electromechanical systems that perform certain activities based on what we want them to achieve. And that's very straightforward. And it could be computational intelligence, which is the branch of AI that deals with data. And that would be our focus today, as we all, as we have it in the topic of the day, which is finding opportunities for machine learning. Okay, I put it there intentionally, machine learning, so that it will not be confused with the more general artificial intelligence. So I try to limit myself to machine learning, which belongs to the computational intelligence aspect of artificial intelligence. So I hope that clarifies the difference between AI and machine learning. Now, machine learning is achieved by following certain procedures, following certain processes, such as knowledge discovery, pattern recognition, and data mining. So when we do these three things, then we will be successfully practicing machine learning. And there are so many methods of implementing machine learning. The artificial neural networks, I would say the popular ANN. Then we come to decision tree, come to different architectures of neural network, the radial basis neural network, the functional neural network, and so on, the deep neural network, random forest, XGBoost, and so on. So all these are the different methods, different algorithms to implement machine learning. So now we can see how the tree is arranged from the umbrella or the root, which is the general AI, to the branches of AI, then to machine learning, which focuses on data, and then the last layer are the various methods of machine learning algorithms. Now, let's take each of the machine learning processes one by one. When you want to practice machine learning, then these are the standard procedures that you have to follow. Everything starts from data, as I've said, because we are under the branch of AI that handles or deals with data exclusively. So everything starts with data. Without data, you cannot do machine learning. That is why when anybody contacts me and say, sir, I want to apply machine learning in my work or in my study, I'm doing master's, I'm doing PhD, or I want to do master's or PhD, can you please advise me, how do I start? I said, well, there are only two ways. Either you have some data, then you think of what you can do with data, or you have some challenges, then you find the relevant data that will help you to address the challenge. So it's either way. So everything starts from data. And what do we do with the data? Sometimes we have varieties of data. So the first thing is to select which part of this data relates to the problem that I want to solve. This is called data selection. For example, you have a whole bunch of data. Okay, let's take an example of a medical file. You have the name, the height, the weight, the medical history, okay, and so on and so forth. And let's say you want to predict a patient's age, okay? For example, you want to predict a patient's age. Of course, you cannot use the street address to predict the age. That doesn't have any relationship. So selecting the right type of data is very important. Then after you have identified and selected your data, the next thing is to pre-process this data. Now, data comes in different forms. When you are dealing with operational data, then be ready for some fight, because operational data is usually dirty. It has a whole lot of issues, missing data, invalid data, out of range data, and so on. So you have to do a whole lot of cleaning, and that is called pre-processing. After you have done all that, if your data is clean, then congratulations. But if you're dealing with raw data, then you have to do a lot of work in the pre-processing stage. After that, sometimes you have to transform your data. Certain machine learning methods require that you normalize your data. When you're dealing with certain reservoir properties, such as permeability, some people like to work in the log domain due to the range of the values. You can have permeability values ranging from maybe as low as 0 to as high as 10,000 millidalcy, for example. So you have to do what is called data transformation. After that, then you go to exactly what you want to achieve based on your objective. Data mining. As we will see in the next part of this slide, data mining can be any of certain activities. It could be machine learning. It could be just some descriptive statistics, or it could be some visualization. You want to see your data displayed in certain ways that will give you certain meanings or certain ways to interpret it, and so on. That is data mining. And this is where you extract some patterns. You want to see your data in a particular way. You want to analyze your data. You want to extract certain information that will help you to communicate to the outside world, to the users that will consume the information. Then at a point, you have to evaluate, let me call it model at this point, because when you have a data mining process, you end up with a model. So you have to check, am I achieving my objective by what I am getting, what I am seeing here? If the answer is yes, then in the result, you have a new knowledge. So the outcome is useful, and you'll be able to communicate that to the clients or to the proponents or to the outside world. However, at any of these stages, if anything goes wrong, you always have the chance to go back to the previous step or even to the very first step. If you are not achieving your objective, maybe you have missed out certain relevant data. You have to go back to the data selection stage. If you are okay with that, maybe there are some noise, some artifacts in your data. So you have to go back to the pre-processing stage. If everything is fine with your data, maybe you need to transform and so on. So it's a continuous loop until you achieve your aim, and then you present your new knowledge. As I've said a while ago, data mining can be any of these. Okay, let me quickly skip that. Now let's come closer to machine learning. We have defined AI, okay, as the science and engineering of building intelligent systems, which is very broad. Now, machine learning, here we try to teach computers. We try to build models that do what humans do. And what do? We learn from experience, okay? It could be in our life, okay, I've been working for over 23 years, okay? What have I experienced so far? I have seen that, okay, if you do things in this way, this will be the outcome. And I have seen this consistently. So that is experience. Or even if it rained yesterday, and while it was raining, it was cloudy at the same time. So if the same thing happens today, you know that, okay, based on what happened yesterday and it rained, then it will most likely rain today. I mean, all things being equal. So this is what we do as humans. So we want to transfer that activity to the computer, okay, by building some algorithms. And how will the computer learn as we also learn? It's from data. And that's why we call our training data historical data, okay? Because the data represents what has happened in the past. And what the algorithms do is to find the hidden patterns in this data, a process that no human can do easily. So we transfer that to the machines. And to go deeper into what machine learning is all about, there are two major types of machine learning activities: supervised learning or unsupervised learning. Let me start with the easier one, which is supervised. It is supervised in the sense that you have both the question and the answer, okay? You have both the input and the output. So you are teaching the computer, that is, you are building a model with some relationship that exists between the input and the output. With this, the machine will learn, okay? And like the example I gave a while ago, it was cloudy yesterday and the temperature was low. These are the inputs. The outcome is it rained. So you can have series of this that happened maybe for the past 35 years, and then you gather all the data together. Now, today, we look at the weather condition. What is the temperature? We have it. And what is the condition of the cloud? We have it. Then we plug it into our model that has been trained with 35 years history. And then the model will be able to give us what is going to happen today. Perhaps it's going to rain heavily or rain lightly, and so on. So that is a supervised learning. You give the model both the input and the output. But for unsupervised, you don't have the output, you have only the input, okay? So the algorithm will help us to discover certain groups, some natural groupings in the data. And this is what we call clustering in another way. And there are various ways you can achieve any of this. Before that, under supervised learning, there are also two things that you can possibly do, depending on the nature of what you want to model, depending on the nature of the target of the output. If the output is composed of numbers like porosity, like saturation, like probability, then you are doing regression. However, if the target is not composed of real numbers, but it is about what we call categorical data, qualitative data, okay? You are modeling facies, for example. Is this rock composed of carbonate? Is it clastic? Is it dolomite? Okay, when you deal with such kind of data that is not numerical, it is rather descriptive or qualitative, high porosity, medium porosity, low porosity, okay? High probability, low probability, all these are descriptive. They are qualitative properties. Then you'll be doing classification. So there are so many methods out there that you can use to perform any of this. And I wouldn't go into that, but just know that there are so many methods and there is no restriction on any of them. So this slide gives us, the generalized workflow for a supervised learning, which is the most common machine learning activities that you will perform in the industry, based on my experience so far. It's also possible to do clustering, but from my experience, we do more of supervised than clustering. So this is the generalized, in few seconds, we start with data ingestion. As I said a while ago, everything starts with data. We do the cleaning, then we build our model. Okay. While we're doing that, we reserve some data to be used to test the model. When the model is ready, we test it with the reserved data. If it's not giving us what we expect, we go back. Okay. Either we go back one step and retrain, or we go back to any of the previous steps. And then when we are achieving our objective, then we have a good model, then we can deploy it to whoever wants to use it. So in all things we say about machine learning, the goal is this. We want a model that is free of these two extremes. Our model is neither underfitting nor overfitting. What do we mean by this? Let us look at this chart. And the y-axis is error. So let's keep that in mind. The y-axis is the error. When you start building your model and you are tuning the model, you are training the model, and the error may start high because you start by, you start from a small level. So the complexity is low, and you are gradually increasing the degree of complexity. So at the beginning, your errors will be high, both the training and the testing. They will both be high. You wouldn't stop at this stage because your model is underfitting. That is, the model doesn't have enough power to do anything or to, to handle the challenge it's going to face. So this is underfitting. This is when both the training and the testing accuracies are low or the errors are high. And then at the other extreme end, you keep training, you keep increasing the complexity. It gets to a point whereby the training is good, okay? The training error is very low, and you feel happy that, oh, I have a good model. But suddenly, you take a look at the testing, the error is high, or the accuracy is low. This is the other extreme, which is overfitting. It means your model is too powerful to handle your data. So it's a compromise, okay? We want to stay somewhere in the middle, whereby we want to avoid that point where the testing error begins to increase far more than the training error. At that point, you want to, let your model stay in that area. Very quickly, and I will not be exhaustive here, just to give you a flavor of what are the advances in machine learning nowadays, so that when you hear about any of them, you will have a glimpse of what they are. And they are all very simple because they follow, the way we do things as humans. The first one is the hybrid learning. Just as we have it in our high school biology, okay, when you hybridize certain species, okay, cow or goat, you hybridize. You bring Bonu brown and you hybridize with Sokoto white. You have a new cattle or a new goat with a mix of both qualities. The same thing happens in machine learning as well. And it's been proven in biology that hybrids are usually far better than the individual components or the individual species that were used to build the hybrids. This was the work I did in my master's and PhD. So I proved that hybrid methods are better than the individual components of the hybrid. And this is a very good example here. This is not a very popular method. It's called ANFIS, Adaptive Neurofuzzy Inference System. When people see it and they use it without knowing, it is actually a hybrid of fuzzy logic and neural networks, and each one is playing a part in the closed box. That is about hybrid. Now, about ensemble. I see people nowadays, they are running Python codes, running MATLAB codes, R codes. They are using random forest, using XGBoost, but they don't actually understand what is the principle. What is the working principle of these methods? Their principles are based on ensemble learning, which means they are not just one opinion that neural networks will give you, not one opinion that SVM will give you. There are actually several opinions about the same problem. Okay. For example, random forest, as the name implies, it is an ensemble, that is a committee, a combination of several decision trees. So each tree will act on the same data to produce its own results. And let's say you have 100 trees in the random forest. You have 100 outputs, 100 results. And then somewhere in the middle, you have a combinator, okay? You combine all the opinions, so to say, to give you a single ensemble output, which has been proved to be better than the opinion of each of the individual trees. Again, this is an emulation of how we humans do things. For example, you want to buy a car and you're confused. Do I buy a Honda or Toyota or GM or whatever? Sometimes we go online to read people's reviews. These reviews are opinions. The reviews could be neural network, it could be decision tree, it could be SVM, okay? When you gather all the reviews, then you sit down. Maybe you wake up around the 2 a.m. and say, okay, which one do I pick out of all these reviews now? But at least collecting all the reviews is of use because you know what people are saying on different brands of the car. So the same thing is happening here. Each model is giving you a local perspective of the problem and is giving you a result based on that perspective. Then you combine all of them. If you are doing classification, for example, it will use majority voting to do the combination to give you a single ensemble output. And if you are doing regression, sometimes, the most common method is to take the average. So it's like combining several good heads. As we say, 2 good heads are better than 1. So here you are combining several heads to benefit from their wisdom. So deep learning is a branch of machine learning nowadays that came up because of the emergence of abundant data nowadays. So it's simply the same thing as the other machine learning methods, but they are optimized to handle abundant data beyond the ordinary level we have been operating on, in the previous years. So I'll keep it like that. And example of each one of them are here. For the deep learning, we have an example of convolutional neural networks. So in summary, we have AI as the superset. Under AI, among other things, we have machine learning. And inside machine learning, we have deep learning, we have hybrids, and we have ensembles. That is the way to summarize that. And then, why is deep learning becoming so popular nowadays? Because unlike what is now called the shallow learning, for deep learning, there is no limit to the degree of its accuracy. If you add more data, of course, more good data, the accuracy increases. But for the shallow learning, there's a limit. Of course, initially, when you had more data, your accuracy improves, but it gets to a point whereby there is no more improvement. So that is how to summarize that part. Now we are into the second part of the talk, which is now, when exactly do we use machine learning? I have to correct this impression. Some people think that okay, machine learning, it is now the magic wand. It has come to erase any method on ground. No, that is not the case. You have to, I see it as a tool, a new tool, or maybe another tool, okay? There are certain instances where it can be used, and there are other instances when it is not necessary to use it. So this is very important because people are presenting it nowadays as if it is the alpha and the omega, so to say. It is the magic one. I mean, it must work everywhere. I say no. You have to sit down and say, okay, this is a new tool. Let me see if it can add value to my workflow. Let's see. If it works, then fine. It becomes my new solution. If it doesn't work, then I dump it and I continue with my conventional method. Now, when can we use machine learning? What are the opportunities? How do we create opportunity to apply machine learning? This is actually very important. Students who wants to apply machine learning in their projects, in their thesis, or even our engineers and scientists that want to, test machine learning to see if it can add value to their work. These are the procedures that we can use to determine if it is really necessary or not. Now, the first one, we think about machine learning when we have a process that is repetitive, but with clear procedures, okay? If it is a kind of activity, then we can bring in robotics. It could be just a robotic arm. For example, in the core lab, all you want to achieve is to, check out a core sample from the shelf, put it on the core table, and slab it. Then return the two parts back to a different shelf. That's it. This is a typical application for a robot. You can bring in a robot and you program it. Start. It will reach out to the shelf, take a core sample, put it on the core table, then switch on the machine to slab it. Then it will be cut into two halves. Then it will take the two halves and put it on the shelf. And it will be doing that repetitively until you ask it to stop or until there are no more core samples. This is a typical example. If it is in form of data, then if you have a process that is repetitive, okay, you can automate this process by writing a Python script or MATLAB program or whatever to automate the process. Now, when safety is a concern, yes, one of the applications of robotics in form of drones, in form of robots, is to keep harms away from human. And as we will see in few slides to come, geologists go to the field, okay? They visit outcrops. Sometimes they climb on the cliffs and so on. There are safety concerns in doing all this. So you can bring in a drone to do that for you, okay?
Doc, apologies, quite an interesting topic, a bit on process check. And I also like to use this opportunity to remark that for the rest people on the call, will slightly overshoot today's meeting, as typical from the normal time. But if you could also try to quite detailed, if you could also try to move a bit, that would help us on time. Otherwise, if we all are happy, we can stay here as long as we want to. That's fine. Thank you.
Thank you very much for the notes. So I will adhere to that. So the next one is when there is no predetermined relationship or equation. I use an example here. You have some data of historical distances and historical times. You don't need a model to predict velocity because there is a universal equation that says if you want velocity, divide your distance by time. No AI here, no machine learning, no need. However, okay, another example, we can calculate porosity from sonic log, from density log, and so on. If the equations are reliable, then no need for AI. You have a very good equation. However, you want to relate certain data that have not been studied before. AI is an opportunity. Grab it. For example, one of the research I'm doing nowadays is to see how I can utilize advanced mud gas data, okay? One of the byproducts of the drilling process to predict some reservoir properties. Here we are talking about, the gases from methane, ethane, propane. Can we utilize them beyond the conventional fluid typing? The answer is yes. I'm getting some good results by value of using machine learning. So this is a very good opportunity when there is no equation, when there is no relationship. Now, there are relationships, but they are too complex to grasp. And in order to simplify them, then you make a lot of assumptions, sometimes that don't even, that are not realistic or that are not applicable everywhere, but you just have to assume some things to keep the equation simple. Then we say, okay, instead of that equation, okay, that will possibly bring in uncertainties, why don't we use machine learning that we just look at your data and then use the pattern in your data to make a prediction? So this is another opportunity. And also, when you have an equation, the equation is not too complex, okay. However, you have to modify the equation slightly for different conditions. And this Archie equation is a typical example. These parameters A, M, and N, they assume different values in different geological conditions. For example, in carbonates, M is set to 2, even though I have proven in another work that this is not true. M should be variable. So this is just an example. So when you have an established equation, but it changes all the time, then this is a good chance to use machine learning. Now, you have some scattered data. Most measurements, especially from from samples, either rock samples or fluid samples that are measured in the lab, they are usually scanty. They are not much. But if you want to have a robust, model, you need them in abundance. We can use machine learning to generate a log from these sparse data. This is another opportunity. Also, you are looking for alternate workflows, okay? Again, you can look at machine learning as an alternative. Also, this is one of the key points nowadays. Most workflows, most traditional workflows are conducted in Excel sheets with macros, with VBAs and so on. But the amount of data we have nowadays is going beyond the capacity of Excel sheets. So using machine learning would be far better, far more efficient than those traditional workflows. And then when you have, you're trying to model certain measurements with some properties, and you notice that the linear correlation between them is very weak. You are getting 0.23, 0.1, 0.2. These are weak linear relationships. If you still go ahead to use linear models, you may not have a very good model. This is a chance to try machine learning. I hope that suffices. Now, what are the incentives that we have nowadays to use, to practice machine learning? Of course, we are in the era of the fourth industrial revolution. The industry is getting transformed. We are dealing with a lot of data. All these are, motivations, so to say. Nowadays, there is more focus on safety in drilling, drones for outcrop mapping. All these are because we care about humans. We care about the lives of people who are working in the field or in the lab. And of course, as I've said earlier, we are in the era of energy transition. We want to keep our carbon footprint low. Machine learning can help us to achieve all this. And also, since COVID-19 started, the rate of transformation, the rate of digitization and the digitalization has increased a lot. So again, all these are bringing opportunities for machine learning application. Then we want to reduce non-productive time. We want to be able to drill ahead of the beats. All these initiatives are coming in order to make our work more efficient, to increase productivity, to utilize data. Now there is emphasis on real time. All those reservoir properties that we usually wait for the lab analysis before we get them, now there are initiatives to have them while drilling in real time. So AI, machine learning will give us that opportunity. Now, let me quickly show you a few examples, and please note that this is not meant to be an exhaustive set of applications. I cannot cover all the fields in the oil and gas industry. These are just to whet your appetite for you to have an idea of how they are being used and what they can be used to achieve. And the objective for the use cases is to reduce operational uncertainties, as you'll be seeing, to reduce operational costs, okay, and the time requirements, to provide missing information in our data, and to increase the time value of our information. And I will start with those examples. Let me start from a geophysics application. Nowadays, there is a lot of research going into using drones for seismic data acquisition. So instead of having a crew of people laying down geophones, everywhere, there have been tests that have seen drones successfully dropping geophones at certain programmed locations. And also there are intelligence algorithms that are used to analyze seismic data, and as well as seismic data interpretation. Coming to geology and sedimentology, as I said earlier, drones are now being used to map outcrops. So instead of, taking your students with all the logistic issues to some sites, you can actually, ahead of time, take a drone, map the outcrop, then using photogrammetry and other technologies, you can actually build a digital replica of the outcome on your desktop, and your students can interact with that. Nowadays, in some conferences, especially during COVID-19, in some conferences, there were sessions for virtual field trips. This is the idea behind it. Still in geology, we have a core description. This is everyday work of a typical sedimentologist. They look at it, they taste it, they test it, they knock it, and so on. Nowadays, using image processing coupled with deep learning, we can actually automate this process so that we reduce human rigor, we remove human subjectivity, and then we try to make it more accurate. And then still in geology, and I apologize for that, I work with geologists a lot, so I think I have more examples in geology. So the thing section, again, has been, not only can be, has been automated to reduce human errors and so on. Also, this is a work I published in 2017. It's about cementation factor, the M index in the Arauchi equation. Based on a certain objective, this data is very sparse. In an entire well, you may not have more than 2, 3, or 4, maximum 5. But if you need a log out of it, machine learning is the answer. If you use any other method like a linear interpolation, extrapolation, it may not be as accurate as it should be. Also, I showed this in a conference last year. When you have missing intervals in your log or any data with high accuracy, with acceptable degree of accuracy, you can actually use machine learning to fill the gaps. Also, this is it's yet unpublished because we are waiting for the patent to be filed. This is an example of predicting porosity using mud gas data. Actually, one of my proponents told me clearly that if I have a model that gives me porosity at 80% accuracy while I'm drilling, I am happy with it because I can make decisions with this. Later, when I get my real porosity or ground truth from the core description, from the SCAL, and so on, then I can validate. But at least while drilling with 80% accuracy, I'm good to go. I'm very happy with it. So this is another successful application of machine learning. Of course, as sweet as it might sound, there are challenges. Okay, as we have seen so far, and as I kept emphasizing, to do machine learning, it starts with data, and not just small data, substantial amount of data, and not just data, but good data. Because if your data is not good, garbage in, garbage out. That has been the slogan. Also, it requires some degrees of expertise. Don't mind people who just know how to write a few lines of code and then they claim to be data scientists or machine learning engineers. No, it requires its own degree of expertise. And that has to be honored. Some people say, well, they are black boxes. Based on my background, I say no. They are black boxes for people who don't have interest in knowing the details. And I usually give an example of this. I have a textbook on neural networks. That's about 800 pages. If it's black box, then what are all the pages saying? They are actually describing the mathematics and all the processes all the linear algebra, all the calculus behind the working of neural networks. So to me, it's a white box, but to some other people, it might be black. However, we can reach a compromise. Also, some people say, well, all these your methods, I don't fancy them. They focus only on data, no physics. Again, I argue here that, well, the data is representing the physics. There's a reason for gamma ray to range from maybe, as low as 10 to like 150. It is the physics. There's a reason why my density will range from maybe 0 to 3 or 4. There's a reason why my resistivity will range from as low as maybe 5 to as high as maybe 500. So the data is actually representing the physics of the problem. So there is physics there. Even though nowadays some people are coming up with some fancy stuff, they say physics informed neural networks. Though there are some background to it, so which is fine. But the issue is, even when we are dealing with data, the data is representing the physics of the problem. And of course, now we are having data scientists being employed in the oil industry. They have close to zero knowledge. This has been a challenge. Just as we have domain experts who lack data science skills, this is also a big challenge. So we want, a compromise. People who can talk to each other, who can work with one another. Now, with every challenge, there are always, ways out. So this, I will end with a few recommendations. Yeah. For example, yeah, please.
Yeah, Dr. Fatah, just please help us to round off.
I'm almost on the last slide now. So we need to invest in massive data acquisition. And not only that, as we acquire data, we should focus on the quality of the data, because this is very important. As I've said, garbage in, garbage out, if you don't have good data that represents the physics of the problem. And also, we should seek to understand the machine learning methods. Many people just use them because the functions are out there, open source, open whatever, we just use them. We should seek to understand what we use. In that case, we will try to whiten the so-called black box. And then we also work with, data scientists should try, like me, should try to work with domain experts to make sense of the data of the problem that they are trying to solve. And also, we should come up with solutions that are robust, easy to use. This will encourage people to like machine learning. And also, we should build integration of solutions instead of having them, in isolated ways. And also, all these skills are very important. I learned that most of my audience are students, so this will be good for them. I should go out there to the industry. You don't only need hard skills, you also need soft skills. So this is very important. And upon everything, we need to be technology driven. We need to be algorithmic in our thinking so that we can help the industry to develop sustainable technology and tools. So I don't want to recap all I have said. So at this point, I'll just say thank you very much, and I'll be glad to attend to your questions. Thank you very much for listening.
All right, thank you very much, Dr. Fatai. That was quite insightful, with a lot to learn, and of course, it took us around the length and breadth of machine learning, going in depth to showing how each of the components of machine learning actually helps in respect to identifying opportunities in the energy industry. I will do a quick recap of the presentation of what you've just highlighted for us, and then we take the questions. This is to help people who need clarity in some areas and also want more information or perspective about one or two things that would actually be done. So first of all, you talked about the energy industry, the need for transition as the global demand for energy increased. There's a need to also see other forms of energy that can supplement that. And then you also stated that oil and gas unequivocally will be available for a long period of time. And then also technology evolution from first industrial revolution to the fourth industrial revolution also was at its peak. And then you mentioned artificial intelligence sitting on the fourth industrial revolution, how it's been the game changer across industries from both especially with respect to the oil and gas industry also. And then you also cleared the confusion around deep learning, machine learning, and artificial intelligence, where artificial intelligence is like the end goal, the umbrella that encompasses the hardware, robotics, software, and also leverages some other algorithm, while machine learning sits beneath it, and then deep learning takes much more below the threshold, feeding into the machine learning space. You also talk about data being being a key component of machine learning processes. And then, of course, we all know that the computer system itself is more of a data input and a data output. And you talk about the process for the data itself, selection process, then selecting the right data for the right problem, the problem objective being defined appropriately. And then, of course, pre-processing the data, because we know that data has a lot of elements of noise and some features that needs to be pre-processed. You talk about noise removal, and also for cases where there are certain features you want to identify in the training process, you have to carry out feature extraction, especially when you're leveraging machine learning techniques. And then you also talk about transformation, where the data itself that is being looked at has a large range of values. You talk about data mining, which gives rise to model, and then the patterns to identify, where you're looking at certain patterns, you're doing classification or regression, as the case may be for supervised and unsupervised learning. You also talk about supervised learning, unsupervised learning based on targets. If targets are composed of numbers, regression is the right way to go. If targets are non-numerical, they are descriptive and qualitative, such as fishy identification, safety helmet detection, and certain properties, classification is the way to go. And of course, you also talked about the supervised learning workflow. You took us through advances in machine learning, the hybrid learning, and also the ensemble learning that involves different machine learning algorithm and models who have different objectives and results, and then combining them to achieve an objective. And of course, you also talk about deep learning that uses large data sets and with supercomputing ability is able to predict the accuracy or to carry out classification as the case may be. Then you also went further to explain, give us some incentives for machine learning, cost cutting for oil and gas, waste reduction, reduction of non-productive time, could also predict rate of penetration, helps in HSE detection violation, predictive maintenance, oil seep identification, and fishes identification. You also mentioned the opportunities for AI with respect to process where there are repetitive procedures, and then safety. You also talk about cases where there are no predetermined relationship. AI can come in, and of course, where the relationships or equations are very complex, AI serves to solve the problem. And of course, you have cases of large amount of data, AI can actually take that in. And you're able to also tell us concise application of AI in the energy industry. You talked about seismic data acquisition, pre-processing and interpretation, the use of drone, image analysis, image feature extraction, and of course, identification, digital outcrops, and some of these which I'm so very familiar with and also agree with you. Core samples analysis for your core analysis from petrophysical logs and thin section analysis, and also generation of missing petrophysical logs, which is also something I've actually done with my team in my current place of work. And then you also talk about reservoir property estimation and also certain PVT property characterization that could be missing. Of course, you mentioned the challenges, which is actually data. One of the first one is data. We need it in large amounts, of course, which is very important. You also talked about having the learning process requires a degree of expertise. Yes, the domain understanding of the problem is very, very important. A lot of people want to do ML, they don't understand the problem, they don't understand the domain, and they're trying to say, I want to use ML to solve a problem. And because of that lack of understanding, they get into it and it's difficult to come out of it. And then, of course, the black box phenomenon, where you need to understand what happens behind the scene of the problem you're solving, how it relates. And then you also talk about the pattern in the data can help with the physics-based information. Some school of thought always say, oh, well, you may need ML, but sometimes you also need to infuse physics, the physics behind what you're doing. While some, with the invention and innovation around machine learning, the data itself seems to be like what you need to run your machine learning algorithm and do your prediction, classification, regression, as the case may be. And then you said some of the challenges, of course, lack of fundamental domain knowledge, which is very, very key. You want to solve any problem, you want to predict petrophysical logs that are missing, or you want to create carry out machine learning detection of HSE compliance, where people are not wearing that they are hard at. You need to understand the domain and see how that knowledge of the domain, you come to look at what ML techniques will actually solve your problem and help give insight as the case may be. There are also cases where you also can use ML to predict production profile for the asset as the case may be, using historical well-test data performance. You also give some recommendations to invest in massive data acquisition, to also understand the techniques in the ML space. And you concluded with the gains. ML helps with cost reduction. The oil and gas industry is driven towards reducing cost, improve time savings. Of course, time is very important. And then the reduction in human interventions and errors. And of course, the gains also increase consistency and accuracy. And of course, the goal is a continuous improvement in ML techniques, and the opportunities that exist for young people, mid-level professionals, and also experienced professionals. A lot of opportunities that exist in the ML space, as we see even the tech world is transitioning fully into the ML space. A lot of solutions will begin to come out. These are the summary of your detailed and insightful presentation, well loaded, from the aspect of the industry to the fundamental understanding of machine learning, to workflows, and also to techniques behind the scenes that operates the machine learning models. You gave us you gave us so much, and we're able to get all you've given us. We go to questions. Because of our time, we'll take questions from, if you have questions, you drop them on the chat area, where we can pick the question, and also we could actually call your name. I don't know if you have a question.
Michael, if I may, perhaps for want of time, we could get one or two voices in the room. And then while we'll carry on with the rest of the day's activity, we could still maintain the chat box for question and answer, and the rest discussion can continue. So if we could have one or two questions voiced in the room, and then the rest will happen in the chat box, so that we can try to not stay too much above our time limits. Thanks.
All right, thank you. So if you have your questions, you could use the raise hand function, and then we'll take your question. Room seems very quiet. Okay, let's take a comment on the chat area. I think we have one from Latif Karim. It says, please, the name of the book on machine learning that Dr. Fatah is using. I think Latif wants to, is asking for the book. Okay. Okay, Latif, you have a question. You could just unmute and then just ask your question.
Hello.
Yeah, can hear you.
Okay, so first, Doctor, thank you very much for the presentation, and Michael, thank you for the recap too. So I just want to ask first about the book. And
Okay.
also that I quite agree with Doctor. Like, I have had a problem where I discussed with someone and the person was saying, okay, what about the physics? I said, okay, because the data is actually a real data. So, and then in the process of acquiring the data, it is the physics that happened when you acquire the data. So the information about the physics is already the data. So I quite agree with Dr. Avi, like, on that. I just like to have the name of the book that Dr. is teaching so that we too can tap into that knowledge. Thank you, sir.
Thank you very much for that. The book I mentioned during my presentation as an example is about neural networks. And it's actually the one that was produced by MathWorks. So it's used to describe the neural networks that was implemented in MATLAB. So I'm sure if you, okay, I have a copy, so I can, it's just about neural networks. I mean, artificial neural networks. I can send you a copy if you, but I'm sure you know about it. So I know you very well. But if anyone is looking for any textbook on machine learning in general, there are so many books out there. But I have some in my drive that you know, I have intentionally saved, and I can share it with anyone. If you contact me, let me even display my contacts on the screen. So yeah, I'm on LinkedIn, I'm on ResearchGate, and you can also contact me via by email. So I hope that is sufficient.
All right, thank you, Doc. I think that was it. We'll take just a second question. On the chat, Mohammed Idris is asking Dr. Fatai if you can just tell us how you used mud gas data in inferring porosity, what models and what example. Maybe just summarize that in probably 2-3 minutes.
Okay. Since you know, we might know about the so-called no free lunch theorem. So there's always the need to search for the best model, you know, for any data that you are using. But for my own data, okay, the best model to me was random forest. And then how did I do it? It was just the gas components that are acquired while drilling. It's part of the mud logging process. So the gases from the light component to the heavy components, as I've said, the C1, C2, C3, C4, C5, up to toluene, helium. There were the 16th one is the total gas, okay, which is C1 to so these are the inputs, and then there are other EUs that you also can try. I don't want to be conclusive because it is all about my own data. Maybe your own data may not require that. It's about you know, do we remove the background effect of the mud gases before we use the rest for our prediction, or we leave them there and then allow the algorithms to handle them on their own. So these are just a summary of how it was done.
All right, thank you very much, Doc. That will be all because of our time. If you have further questions for Doc, you could actually pick his email address on the screen, fatayamifoshi@yahoo.com. Send him questions, and also he would respond accordingly. Thank you for this session. We hand over to the PC will take over from now. Thank you very much. Thank you, Doc, and thank you, everyone.
Thank you very much. Thank you. Please, wherever you are, you could do the presenter and the moderator the honors of putting your hands together, you know, just out of excitement, and thank you. Well received. We went quite a lot above the time, but I think it's worth it because we still have over 50 persons on the call. We don't take your time for granted. We just thought in the quest for knowledge, sometimes sacrifices like this are done. We'll then retire to the rest of the SPE program. But because I know we've eaten a lot into the time and some persons might want to log in. I crave the indulgence of the senior members and SC that we take the photograph, the group photograph at this hour, so that if the presenter or the moderator or any other person wants to sign out, they could do that freely. So let's get the room. Simeon, if there are no objections to that from the board members, permit us to take the pictures, the photograph session for documentation and the right audit trail so that we can continue the rest of the program. Simeon, over to you. So as usual, can we please switch on our cameras? And then Simeon will do his thing, and then we carry on with the rest of the program. Hi, Mabum. Hi. Oh, Michael. Good. Quite an person. SC, are you still on the call? PC. SD, Joe. Good day, Doug.
Yeah, some video are still coming up.
Okay, give it another.
Hold on, please.
Okay, we'll do a countdown. We have 5 seconds left. Yeah, a little smile will help. 3 seconds. Okay, the last shot. Yeah, we are good.
Excellent, Simeon. If we have some senior members and directors like Dr. Joe, Prof, we could just give them 1-2 minutes to make some remarks and also extend our appreciation to our speaker and moderator.
Thank you. So can we go back to the pack now so that SC, while you're on, please, let's make the presentation immediately before you go.
Dr. Joe can make the presentation.
Okay.
That's an immediate past section chair. So
indeed.
I'll be glad to have him make this presentation.
Thank you very much. Dr. Joe, good day, sir, and welcome.
Good evening, everyone.
Good evening, sir.
On behalf of the Section ESCO and members of Section 103, I thank Fatai and Michael for this wonderful presentation. I think you did a very good job. Thank you for accepting to give this presentation to the section. May I present this certificate of appreciation to you, Fatai, on behalf of the section chairman who has asked me to do this, and the board entirely. Thank you very much for coming and for giving us this wonderful talk.
Thank you very much. I appreciate it.
Again, Michael, you did a wonderful talk in your moderation. I'm really impressed because you took us through the length and breadth of the discussion. And that shows in-depth knowledge you have on the subject. Again, on behalf of the section chairman, and members and board members of SPE Section 103, I present this certificate of appreciation to you for participating in this talk as a moderator. Thank you very much.
All right, thank you very much.
Indeed, in the digital world, The digitalized copy will be sent to you to your email box accordingly. Thank you very much once again.
All right, thank you very much.
Okay, ladies and gentlemen, we've listened to a very sound technical presentation. And this is also to remind us for a call for sponsorship for our technical events. You could imagine if this such wonderful lecture had happened in a face-to-face scenario, we'll have enough time to shake hands with the moderator and presenter, ask our questions in a face-to-face manner, and enjoy all that comes with the face-to-face incentives. The slots are also still available and open for companies or individuals that would like to sponsor our monthly technical meeting. However, there are still some virtual slots for very sound and highly competitive presentations. Let the pool come in. Let's get your presentation in the pool by starting with a topic and abstract, and we'll review it and assign you a technical date accordingly. But please take this message to your company, and also we have an opportunity where we can discuss what you do as a company and your technical research in our monthly technical meetings. For sponsorship, you can reach myself, the SC, or any board member for your bookings to be made. PC also. Thank you very much. I'd like to invite Dr. Okereke to take this session, please, Doc. Is Dr. Okereke still with us? MWC, yes. Yes, I still see you on the call. Hello, Doc. Okay, Simeon, could you take it on their behalf? Hello, Simeon.
Yeah, I can hear you.
Okay, could you please take this on behalf of the membership?
Okay, good evening all. So this is just like a reminder to all SPE members on the call. For those who have not renewed their membership or you are yet to renew your membership, so this is like a call for you to renew your membership. And just as we know, SPE is a place for all oil and gas industry professionals and students, regardless of your experience or course of study. For those who are not yet member of SPE, or you want to be part of SPE, so there is a place for you. You can register and be a member of SPE. So we have a student membership. We also have young professionals and also senior professionals. So everyone is encouraged to be part of this, and we have several benefits for being a member of SPE, just as you can see on the right-hand side and also below the chart. So those are some of the benefits you can derive for being a member of SPE. And also these are some of the activities carried out by our section, Port Harcourt section. So just as you know, Port Harcourt section is the second largest in Nigeria, covering about 6 states with 13 student chapter. So you can reach out to the membership chair and also the assistant membership chair. You can see the contact on the screen, or you can probably better still send email to spepac@gmail.com for prompt response, and we can take it up from there. Thank you very much. Over to you, Doc.
Sorry, thank you very much. Thank you very much, Simeon, for stepping in there. We have some upcoming events. Quite busy. Is there a YP chair? Is YP chair around? Because I know there are balls on the symposium. There are balls on charity tournaments. Is there someone on the call that could do justice to this?
Our program, PC is a program.
PC. Okay, thank you. Madam, could you please help us talk around this upcoming event?
Okay, yeah, so good evening, everyone, and thanks for joining for the monthly technical meeting. So apart from the meetings, the technical meetings that we also have a lot of events that keep us together in section 103. For the next 1 month, we have a series of events that will benefit us as members and non-members. The first, we have the football tournament for charity. During the tournament, we're going to see opportunity of 2 groups playing football to win a trophy. So it promises to be fun. And the date is Saturday, 1st April. We will also have an opportunity to create genotype awareness and blood donation day. So we look forward to seeing all of you come out in your numbers to join us in ensuring that this event is successful. The venue is Uniport Football Stadium, Abuja Park, and time is 10 a.m. All right. So let's go to the next event. Then there's a burning one, the 2023 Young Professionals Symposium, where the topic is secure and sustainable energy. It's a 2-day event, fully packed, hybrid. I bet you, if you attend this event, you will not go empty. There are a lot of things to learn. There is debate, there is career fair, there is energy challenge that is already ongoing, and then there are prizes to be won. I don't want to leak out the things that are going to happen during this symposium, but kindly, there's a link, there's a registration link, and the fee is just 3,000 naira. But what you're going to get out of it, I promise you, it's a life-changing event. Let me keep it at that. Then we also have the International Women's Day celebration. It's happening from the 29th to 31st of March. We have a lot of events that is going to happen. We're going to feature girls in STEM. There is also the charity for widows empowerment, and we'll have a grand finale. This is going to be purely online. Please ensure you register so that you'll benefit from all these events that are going to happen between tomorrow and 1st of April. Thank you very much. Hello.
Thank you. Lots of mouth-watering events, capturing all sphere of life, from social to technical entertainment, particularly the YP events, symposium, and also the International Women's Day. I'm deeply committed, so you will hear more of us in that event. Thank you very much. To wrap up, SE, Mike, pass to you. For your final words, remark, and then we can take a closing prayer and bring this meeting to a close. Do we still have SE on the call?
I think you drop off.
Okay. Simeon, help me. Any senior members still on the call? We could also. Ella, if you can, please, could you give us a closing remark?
The SE is back.
Oh, SE is back? Oh, okay. SE,
Yes, I'm here. Good evening.
Okay, now,
Once more.
yeah, we're calling you one more time. We're just about the end of the program. I would like you to give us closing remarks so we could bring this event to a close after that closing prayer.
Okay. So let me especially appreciate every one of us in this call for the monthly technical meeting. I recall that we had picked at 69 and we are now 27. So many thanks to everyone that is in the call. Special thanks to senior members. Prof. Onyekon was in the call. Our immediate past chair, section director, Dr. Joe, very supportive, and many others. So between now and night, we have a full basket of activities and events. Please, again, we count on you and all of us to show up, turn up, and participate. All things being equal, the launch and learn should happen in Total Energies, thanks to the ED, Engineer will be a member. So it promises to be quite very interesting. A few courtesy visits is being lined up. YP Symposium, it's loading at a very fast pace. Charity event is first of April. I mean, so we've seen several activities. So please, let's be involved. Let's get involved. Let's get into action. We are SPE, and this is what makes us. I appreciate all the time, efforts, energy, resources that every one of us have always been putting into volunteering for SPE's activities. Thank you very much and have a beautiful evening.
Thank you very much, SC. Thank you. So much words said already. So take your closing prayer.
1 minute, please, if you allow me, please.
Okay, please, go ahead.
Yeah, thank you. Just to announce that IPTC 2024 has been scheduled to, be in Dhahran, in Saudi Arabia, and I know that students are usually sponsored to attend these events from all over the world. So, in case any Nigerian students are attending, please let me know. This is my base, so I will be glad to catch up with you. And in case also any of the board members, any of my colleagues are coming, let me know. It will be a great opportunity to hang out technically and socially. Thank you very much.
Thank you. I hope some of us take you up on this offer. It sounds like there is a free accommodation. Thank you very much.
Doctor, thank you
I don't
very
guarantee
much.
that.
It's really a good it's really a good offer from you. We really, really appreciate this. This is
there are hotels around there.
No worries. Get your house ready. We would fill up that house.
We'll come and sleep in Aramco campus.
Thank you, Doc. Thank you. We appreciate it.
Okay. Do we have a volunteer for a closing prayer or we'll do the national anthem? I think someone should pray for us. Any taker?
Don't worry, TIT. I'll help you call names now.
Yeah, I want to take the closing prayer.
Oh, very well. Thank you.
All right. In Jesus' name.
Amen.
We thank you, Lord, for the grace of this meeting. We thank you, Lord, for the success of everything that has been discussed here. May your name be exalted now forevermore. Oh, Lord, we pray that whatever we have learned today may stick to our brains, where we learn and in our future endeavors, so as to learn more, just as we have learned and relearned in this program. May the future monthly technical meetings be as successful and informative as this one. This and many more ask for to Jesus Christ our Lord. Amen.
Amen.
Thank you all.
Thank you. Thank you. Thank you. Thank you very much, Simeon, and everyone on the call. Good night and see you next time for other events.
All right, good night. I see, good night.